Okay, thank you all for your patience. Sorry about that. I'm going to be presenting about NASA's Exoplanet Archive today and the ExoFOP. And I am a staff scientist at the NASA's Exoplanet Science Institute, which is located at Caltech. And there are many people who work on this project. I'm just one of them. We have a whole team of developers. Um, we have database people, we have scientists, and so it's a large group effort for more than 10, 15 people who work on Exoplanet Archive at some capacity, and I'm just presenting on behalf of everybody. Um, and so I'm sure a lot of you have used the Exoplanet Archive before, but hopefully you'll learn something new today. And for those of you who haven't used it, you can have a nice introduction. So, what our main data holdings at the Exoplanet Archive are a compilation of literature from the literature of confirmed exoplanets. And we have a slightly different definition. If you notice down here, our mass cutoff is less than 30 Jupiter masses than what Jean presented earlier today. So if you see slightly different numbers of planets on these two different databases, this is probably why. And so our main data holdings can be found both in two large tables that is under this data section on our website, and also they're organized on system overview pages. The two main data tables that we host, the Planetary Systems table and the Planetary Systems Composite table, both only have confirmed planets, but our system overview pages have a mix of confirmed planets and candidate planets from the TESS mission, from K2, and from Kepler missions. So here's a nice example of an overview page for a system that has 2 confirmed planets and 3 TESS candidate planets. And if you're interested in candidate planets, you can also interact with candidate planets through some of our other tables under the data section. So we have lists of K2 candidates tables and things. And so these main tables, they can be sorted, filtered, plotted, downloaded, and interacted with really easily. And the two main tables that we have, the difference here between the Planetary Systems table and the Planetary Systems Composite table, is that the Planetary Systems table have uh, internally accurate planet parameters pulled from a single literature source in each row. And so there's one publication per row, but there can be multiple publications per planet. On the other hand, the Planetary Systems Composite table, we take the most complete and accurate data set for a single planet and then fill in any missing values from anywhere else that we have them in the literature from different sources. And we also perform calculations in order to get the most complete set of parameters for each planet. So there's only one planet per row in this table. So besides those two main holdings tables that we have and the system overviews, we also have large holdings of contributed data sets. So some examples of those are that we host millions of light curves from different surveys. Transit surveys like CELT and also microlensing surveys like MOA. And I'm not going to talk about these in detail, but just so you know that they're there, we have them. I'm going to give 2 examples of brand new contributed data sets that we either have just released or are going to release at some point in this year. And if you have a large data set that you want to be available to the public, you can let us know, and we're happy to host more contributed data sets. We also have tools for interacting with all of this data that we have at the Exoplanet Archive. So we have some tools for observation planning. We have tools to calculate parameters, missing parameters. And we also have tools for fitting the data. So we host a version of ExoFast that Jason Eastman will talk about later today. And one of the new tools we have for observation planning is we have a transit and ephemeris tool that we've had for a while. So you can put in a single target if you're interested, or a whole list of targets, and choose either space-based observatory or Earth observatory, and calculate when the transits are going to happen. The tool will calculate when transits are going to happen. And now we have this new plot here that actually shows where the transit will occur on an air mass plot. So if you're trying to plan follow-up observations of a transit event from the ground, this is really useful to figure out which nights are the best nights for planning your observations. Going into two of the new contributed data sets that we are just releasing. The first one is a contributed data set from Inara, and this data set contains 3 million synthetic spectra of rocky exoplanets. And it contains spectra for conditions from a optimistically habitable Venus through an optimistically habitable Mars in temperature space. And they're simulated for a 15-meter telescope at a resolution of 2000 with lots of different parameters. And so you can interact with these by going to our data and looking at the PSG Inara dataset tab. And you can see the spread in the top here. You can see the spread in all of the different models that we have, and interact with the models, sort them. And then down here, this is plotting an individual model. This is showing an individual spectrum where you have chosen now a certain planet temperature and a certain surface pressure. The second new contributed data set that I want to highlight is that we're going to be hosting the CUTE data set. So CUTE is the Colorado Ultraviolet Transit Experiment. And this is a CubeSat that is conducting transit spectroscopy in the near ultraviolet. The goal of this is to characterize mass loss and the ultraviolet environment, and how kind of a lot of these hot gas giant planets are interacting with the radiation environment from their host stars. So this will look at 10 known hot Jupiters, and each target will be observed for 10 or more transits. And you can see here we'll both host the transit light curves shown at the top, and also the transmission spectra shown at the bottom. And we're looking at a first release date for this data set in 2023. And so that'll be available soon, and it's going to be a really exciting data set. I also wanted to highlight, so currently we have some transmission spectra that you can interact with under our transmission and emission data tables, but we're actually working to upgrade these tables to be a much more interactive and usable environment. Also, it'll be much easier for us to keep up with the literature. Transmission and emission data in the last 5 years has just exploded, and we're expecting that to be even larger with JWST. So this will help us to keep up with the literature and keep a much more complete list of final transmission and emission spectra. So the new table is going to look something like this, where you can sort on what planet, whether it's a transmission and emission spectra, a facility, and then once you click on whatever transmission or emission spectrum you're interested in, the table over here will show you the actual data points, and you'll be able to see a plot of the transmission or emission spectrum. And this can easily be, you can add multiple planets to the same plot, and you can easily download the data. And this is kind of the first step of the upgrade that we are planning to do with atmospheric data. And we're also going to do a lot of other upgrades, like including tables of which atoms and molecules have been detected in which planet. And we're also planning to add functionality for all of these new types of data sets that show atmospheric characterization, like phase curves, high resolution observations, and spectra of directly imaged planets. So since this is a meeting about people who are developing their own code, we thought we would quickly put a slide in about how you can integrate the holdings of the Exoplanet Archive directly into your code. So you can do this with either TAP or with AstroQuery. So here are two examples where you can pull directly from our planetary systems table to get the most up-to-date masses and radii and plot a mass radius diagram. Or you can use AstroQuery to query for a certain planet. So here I've queried for K218b from the planetary systems composite table. And then once you just ask for K218b parameters, you can kind of use those in your code however you would like. And so we also plan to be able to have our tools, like the transit and ephemeris tool, be able to be called from your code in the near future. And the last slide, I just wanted to quickly say we also host ExoFOP. So instead of the last few slides that I presented, those are all kind of curated data sets that we maintain and that we are the only ones who are updating. ExoFOP is different. So this is a community service, and anybody in the community can upload different observations. And the goal for this is to make it so uh, validation of transiting candidates is a community effort, and this effort is not being duplicated by multiple groups. So we have ExoFOP websites for tests for K2 and Kepler, and these are all now combined into one location. This was a recent update. And you can see here, we have all the different TOIs, and if you click on each of the TOIs, you'll be brought to an overview page where you can upload whatever observation you would like. So here are imaging observations, and then there's spectroscopic observations. And you can access all of this data and download it through a number of PHP scripts and other ways. So hopefully everybody learned something about Exoplanet Archive today.
Thank you very much, Aurora. Very nice talk. Is there any question for Aurora?
Hey Aurora, that was awesome talk. I just posted this in Slack, but would you be willing to share just that one slide on how to bring the archive into our own codes? Because I bet a lot of people would like to review that um,
Yes, and
over
I'm
the course of
happy
the
to
week.
share the whole slide deck if that's useful for people as well.
I think that would be awesome. Thank you so much.
Okay, great.
I think Avi has a question, maybe.
Yeah, Aurora, great presentation. Really exciting to see all the new stuff that you guys are doing. Um, I was wondering what the process is for kind of proposing to get your, say you are PI or, contact for a new mission or CubeSat or something like that. How do we, the community, work with you guys to get data sets, ingested and or at least approved and in the process of that?
Yeah, great question. Like I said, we are definitely open to hosting more data sets. So oftentimes we have PIs approach us when they are putting in for acquiring funding. And so we're happy to work with you and write any sort of um, statement of support that says we're happy to support um, if you receive the funding. And so yeah, we have the resources, we have the bandwidth for the most part. So if you're interested, just reach out and we can work together on a plan and helping out with any support letters that you need for grant purposes.